So an application-specific configuration is one that Denton has configured to do a particular job in industry, a particular film called laser facet coating or indium bumps, and we've optimized the hardware by partnering with sometimes dozens of different customers. And all of that process knowledge gets built into the tool, and we strip away what's not needed, and we add what is needed and only what's needed. And this gives you the best performance and the most bang for your buck, based on our knowledge working with the whole industry rather than just one person. If you have a hardware-centric view, you can give me what we receive these RFQs for a chamber that's this size, so many guns, an ion source of this particular one, and they just list all the parts. That's great if you know exactly what you want and what you're doing, which a lot of our customers do. However, all Denton can do is then build that recipe and give you the bucket of parts that you ordered. And we can assure you that everything is functional, but we can't really say it's appropriate for it's gonna work for your process. If you aren't quite right, then you're gonna get a bunch of functional hardware, which you then have to qualify in your system, develop your process, qualify in your production line, and go from there. With an application-specific one, we'll give you a tool that we know works. We'll give you the process. So you're starting from a process-qualified tool, and you get a much faster time to production for that system, potentially. It may cost a little more in terms of capital, but you save so much in terms of, and it may not cost more in capital because you may have overspecified the tool. But anything that's on there, we assure you is necessary for the process. So that time to production can be greatly reduced by buying an application-specific tool. We've recently celebrated the 10th anniversary of our Customer Application Development Center, the Apps Lab. We have a large suite of tools there. We have sputtering tools, we have evaporation tools, we have PIB-CVD tools, the Voyager platform, the Integrity platform, and the Discovery platform. We also have a lot of metrology associated with those sort of applications. Recently, we've been investing quite heavily. We have 3 PhDs full-time in the lab. We have 3 full-time staff members dedicated to running demos and development. And then we're also adding capability to the lab with our newest technologies and acquisitions. So we've recently added a PIB-CVD system, which is cranking through application after application. We've added an Infinity FA tool for failure analysis, so we can help customers directly with process development and demos. And we've added an ion beam, a wafer-based ion beam deposition and etch system, so we can focus on wafer-level etch and deposition applications for ion beam sputtering. In addition to the process equipment, we've also added a scanning electron microscope to the lab to allow us to properly analyze a lot of the results and work with customers better. What these additions do is they allow us to work closely with customers in ways that they're going to use the tools, both for development of new applications and demonstrating existing applications. Additionally, the lab serves as a platform for new hardware and software development for engineering. So when we want to try new components, we can test it out in the lab prior to deploying it on customer equipment. So it's much more mature and safe to deploy without fear of failure in the field. Well, we work closely with the customers, first to understand the required film properties they're looking at, the substrates handling requirements, what are they trying to put it on, and how can those be held and maneuvered through our systems, and the throughput requirements. These all drive very different solutions. First of all, you have to have a film that does what you want, or there's no point in continuing the conversation. You have to put it on what you want, where you want. That's another consideration. And then you have to do it fast enough to make commercial sense. As we develop this information together with the customer, we can refine what we're offering from our portfolio of standard systems and platforms. For example, for magnetron sputtering, let's say one of your key process requirements is you can't break vacuum between 3 different materials. This is a very common requirement. Depending on the substrates and the throughputs, it could be a simple Discovery 200. You can have 3 or 4 cathodes in a single chamber, very economical. You can have that with a load lock. that might not go fast enough. That might not be good enough uniformity. Okay, then we can move to a Versa cluster tool with multiple modules and single large area cathodes. That'll go very fast, maybe more throughput than you're looking for. Depends on your requirements. Also, it could be a very large throughput application when non-standard panels or something, and then the Phoenix might be appropriate. Or you could be looking for the very best possible uniformity you can get on a 200 millimeter wafer, and then our Isoflux might be appropriate. Also for curved substrates, you can't do better than our Isoflux technology. That's going to be the best possible uniformity you can get on highly curved substrates. So we take all that information together that we've developed with the customer, and then we come up with the appropriate solution for them. Denton's roots go back to Richard Denton working in Franklin Arsenal and starting before World War II, and then he founded Denton Vacuum in 1964. There's been a large number of firsts. Was doing a little research, and some of these still are very applicable to what we do today. The microanalysis, for example, we did the first magnetron sputter coating for samples. We still have that technology in our Desk 5 sample coaters for SEMs. And that was in the 70s that we did that. In the 80s, there was work on ion-assisted deposition and developing ion sources and magnetrons. So the very first starting to tailor film properties with the use of ion beams and ion assist. Lately, we've been focused on both developing and acquiring new technology, patented and proprietary. So we've been issued and granted a number of patents on our plasma technology, our plasma ion beam technology in particular, both our Endeavor circular ion source and our PIB-CVD linear source. We've also acquired a fair number of patents through 4-wave and Isoflux for medical applications, as well as plasma control, I would say, for bias target sputtering, substrate bias etch. These are excellent patents that are very closely aligned with what we're doing in the marketplace. So recently we had our first ion beam sputtering for microbolometers sold through Denton. We also sold our first and second bias target sputtering system. Both of them are for laser facet coaters. This system gives you the best possible film, the highest density, lowest contamination possible with PVD sputtering, which is very important for laser facets because that can allow you to run at a higher power level per diode, so you get more, to use the technical term, poop out of each laser. So higher power per device, which lowers your dollars per watt. So more power, less chips is better for everybody. So that higher laser damage threshold is critical to enabling that move to higher power, and the bias targeting sputtering is a critical enabler of that next level of performance. We've also sold several Infinity FAs recently. Some were new to a new customer, as well as repeat business to an existing customer. So we've 3 systems to 1 customer, one of the major semiconductor manufacturers, as well as several national labs. Infinity FA sales, these are for failure analysis, delayering of microchips. So individual ICs, you delayer those layer by layer in order to look for defects. These are tools that need to be optimized. So we sell these into research labs initially at a major semiconductor. It'll go into their R&D center, but then we've recently sold several more to 1 customer that are going to the fabs. So moving out of the lab and into the fab for real-time failure analysis. This is a much larger market than just the R&D guys, and this is really important. It means they've adopted the technology and they're ready to deploy it in all their fabs throughout the world.